Okay, this is a little bit more from lesson 8.2. So a few things that I didn't cover quite yet. How would we graph a line from an equation? So we were doing that before when we had, the bread and the hour, and we had that the number of loaves of bread was 3 every hour plus the 2 from the night before. And when we wanted to put a point on that graph, we said, well, what was the hours? Oh, let's put, 2 hours in. So we'd say 3 times 2 plus 2 equals the bread. And that would be 6 plus 2 or 8. 8 for the bread when the hour was 2. So then we could plot the point 2 hours over and 8 breads up. And that's how we made that line. Well, let's look at how we would do that if we just had the equation and we didn't have any practical example for it. So we had the equation 2x plus 4y equals 8. We need to put some points on here and then connect the points with a line. And what you will know from geometry or maybe just inferring, if we have any 2 points, we can make a line between those 2 points. When we are graphing a linear equation, we only have to get 2 points in order to make a line. Any other points that we were to get out of this equation should fall on the line that we already have. So let's look at how that would work. I'm going to pick the easiest things to do for this graph. Usually the easiest is to put 0 in for x or 0 in for y. So to get some points on the line, we only have to put in one number and then solve for the other number. Let me show you how that works. If we say that x is 0, then our equation up here becomes 2 times 0 plus 4y equals 8. And then I'm going to keep going. 2 times 0 is 0, so I don't worry about that. I have 4y equals 8. I can divide by 4 and say that y equals 2 when x is 0. So this point, my xy point, is going to be 0, 2. Now I need at least one more point to get a line. So I'm going to go with y equals 0. It doesn't matter if I put in an x value or a y value, whatever you want to try to solve for the other one. So that would make this 2x plus 4 times 0 equals 8. This becomes 0, so I have 2x equals 8. I'm going to divide both sides by 2, and I get x equals 4. So this point is 4 for my x and 0 for my y. Now, these are usually the two easiest ones to get, but you could really do any. You could say, I want x to be 2. So what is it when x is 2? Well, I just plug in 2 for x, so I say 2 times 2 plus 4y equals 8. 2 times 2 is 4, plus 4y equals 8. I'll subtract the 4. I'll have 4y equals 4, and then I would divide by 4 and say that y equals 1. So when x is 2, y is 1. So you can get as many points as you want, but you only need 2 to make the line. Let's use our first 2. I have 0 in the x direction and 2 in my y direction. That makes the point right here. The second one is 4 in my x direction, but 0 in the y direction. So that makes that point right here. If I connect those in a nice straight line, remember that I want to go past both points that I already have, because this line has lots and lots and lots of points. So I would even keep going with it. I can keep going infinitely long in both directions. So please, please, please don't stop drawing between your two dots. Draw past the points that you plotted and make that straight line. Remember to use graph paper. Use a ruler or the side of another piece of paper and make your line as straight as you can. Now, I said that this point should be on the line too. Well, let's check. 2, 1. Oh, that point's right here. It does fall on the line. What other point do you think might be on here? Well, I don't know. It looks like it crosses right here. I bet you -2, 3. -2, 3 is on that also. Let's see if it is. We could plug it in. We could say 2 times -2 plus 4 times 3, is that equal to 8? This is negative 4 plus 12. And yes, 12 minus 4 is 8. So that works. I bet you this point here is even on there. I don't know what that point is. I would guess negative 1 and then 2.5. And I bet you if you plug in negative 1 and 2.5, you would also get that that point is on the line. So again, it doesn't matter what you use right here. You just need to pick an X or a Y value, set it in there, and solve for the other one. Now, if you get decimals or fractions, it's going to be a little harder to plot that point, but it doesn't mean that it doesn't work. It just means that it's harder to estimate on your graph. So go with ones that work out nice whole numbers to make a nice pretty graph. But know that all those numbers in between, all those fractions in between are still on the line. The last thing I want to cover is how do we know if it's a linear equation? We've been graphing all of these and they have been lines, but how do we know if it's a linear equation? How do we know if it's going to form a line? Well, there's actually lots of forms of a linear equation, but one of them that we'll talk about today is called standard form. So the standard form of an equation looks like this: ax plus by equals c, where a, b, and c are integers. This is a big deal. They're positive or negative, but they are not fractions. Notice that the x and the y, they're not squared. They're not multiplied together. They might have a number in front of them, but that's it. And in this standard form, both the x and the y are on the same side of the equal sign. Okay, so let's look at some examples. 3x plus y equals 8. X and y are on the same side of the equal sign. There are whole numbers or whole integers in front of them. This one, y equals 8. And you might be saying, but there's no x. Well, there's not. Perhaps there's a plus 0x in front. Oh, so x and y are on the same side of the equation, and 0 is an integer just like 1 is an integer. So they do have integers in front of them, and they're on the same side of the equation. We just happen to only write the y equals 8. So this is still in standard form. Last one, 2x minus 7y equals 16. Well, that's just a negative 7 in front of the y. And there's still x and y, they're still integers, they're on the same side of the equation. So all of those are in standard form. Now we're going to look at linear equations that are not in standard form. So these are still linear equations. We have a y and we have an x. They're not squared or cubed, they're not multiplied together, but they're not on the same side of the equation. So this is still a linear equation. Here's our x and our y. Not squared, not cubed, not multiplied together, but we have some fractions. So that's what makes it not standard, but it's still a linear equation. What could I do to this equation to make it in standard form? Little bonus question here. Remember, we just went over how to get rid of fractions. If we multiplied everything in this equation by 4, it would come out to be 1/2 times 4 would be 2x. Y over 4 times 4 would be y. And then negative 5 over 4 times 4 would be negative 5. Now, this is in standard form. So we can convert to standard form when we need to. Now, this last one, we have x plus y minus 8 equals 2x minus y minus 12. This is still a linear equation, but it's not in standard form. We have multiple x's and y's. They're not multiplied together, and then they're not squared. We could get them on the same side of the equation, right, by just subtracting them over. So how could we fix this to make it standard form? Well, we would want to move the x's and y's to one side and the numbers to the other. So if I add 8 right here, and I add a y and I subtract this 2x, so I'm getting rid of these on this side. Over here, I'm going to make it negative 4. If I do the same thing, I'm going to minus the 2x, and I'm going to add the y. This one becomes 0, so now I have negative x plus 2y equals negative 4. So if you can rearrange it to make it standard form, then it's still a linear equation. Okay, our last set of them, not linear equations. So right here we have x squared plus 3y equals 15. This x squared, that makes it not a linear equation. This next one, xy plus 8 equals 12. I said we can't have the x and y multiplied together, so that one's not going to work. Now this one is a little tricky. 1 over x minus 2y equals 6. Well, the x and the y aren't multiplied together, so why isn't this one a linear equation? If you were to get rid of the fraction, you would be multiplying everything by x. When you do that, you would have 1 minus 2y times x equals 6x. So in essence, it is multiplied together right there. You would have the x and the y multiplied to get rid of that fraction. So anytime you see an x or a y in the denominator, it is also not a linear equation. Also, please note, I just changed the homework. I added this right here, and I reduced the number of equations that you're graphing. So those are the changes on your homework.